Hi, welcome to PulumiUP 2025. My name is Joe Duffy, founder and CEO of Pulumi, and I'm super excited to welcome you here today. We're going to take a look back at what we've been up to here at Pulumi, hear some exciting stories from customers out in the field and what they're building with Pulumi in the cloud. We'll have some exciting new product announcements to share, and we'll see some demos in action, and we'll learn a thing or two that will hopefully help you in your day job. But first, a look back. Amazingly, we just celebrated our 8-year anniversary here at Pulumi. We started back in 2017 with a vision to democratize the cloud and just make it so much easier, more accessible, fun, and powerful. And I'm proud to say that, we're doing just that. We also launched PulumiUP first 5 years ago, and we've done it every year. It's one of my favorite times of year. We get to celebrate you, the community. Always some exciting new product announcements, and we won't let you down this year, and talk about what's next, what's on the roadmap for us. As part of democratizing the cloud, we wanted to bring the entirety of the cloud to your fingertips, and we did that by supporting all clouds and all languages. We took a different approach for infrastructure as code, where we stood on the shoulders of giants and used general purpose languages like Python, JavaScript, TypeScript, Go, Java, and yes, even YAML. We now support over thousands of clouds. We've gone from hundreds to thousands over the last year, and that includes public clouds like AWS, Azure, Google Cloud, private clouds like vSphere, cloud-native technologies like Kubernetes and Helm, even SaaS providers of infrastructure like Cloudflare, MongoDB, Snowflake, Datadog, and others. Thanks to this innovative approach to infrastructure as code, Pulumi is now the most vibrant open source infrastructure as code technology in the ecosystem. Even compared to OpenTofu and Terraform, we see more than 2 to 3x the engagement across key open source metrics like pull requests merged, issues closed, and more. We now count over 350,000 members of the Pulumi community and have seen over 1 million downloads per week, both testaments to the amazing growth and excitement around Pulumi's open source ecosystem. And it's been a busy year for us here at Pulumi. We ship a lot. I think on average, we ship 1 to 2 times per week. You just go check out our blog, a lot of exciting things there. You can go back in time and see what we've been up to. That includes trying to be the best infrastructure as code we can for you in the community. We've recently improved our component model, so it's easier to create infrastructure abstractions that you can share and reuse in your team. We introduced a new policy violations page so you can see where your infrastructure is or is not compliant. We introduced support for any Terraform provider. So if there's a Terraform provider in the ecosystem, you can plug it into Pulumi, use it from your favorite language right away. We added customizable naming schemes to improve zero downtime deployments with more flexibility. We've introduced support for an array of new tools in the language ecosystems, including Python with rich package managers, better typing, IDE support, and more. And we continue to improve the performance of the core product, including radical changes to the way that we encrypt and decrypt secrets, so that as you're sitting at your CLI typing away, things are as quick, fast, and enjoyable as possible. We're also working to make migration easier. We know that a lot of folks want to get to a world of 100% Pulumi, but have some legacy that they have to deal with. And so we've vastly improved the ability to convert existing Terraform code bases entirely over to Pulumi in your favorite language. And that includes even porting Terraform modules to Pulumi components. We've also embraced the ecosystem by supporting a wide array of other integrations that, we would not be Pulumi were it not for all the cloud providers, all of the other tools that we integrate with. That includes Azure Native 3.0, which is a vast improvement to our Azure provider, which already has nearly 2x the coverage compared to the Terraform Azure provider. That means the full entirety of the Azure platform is at your fingertips. Improve the performance there by 75%. So the size is much smaller, even though we support the entirety of the Azure platform. Pulumi Java is now generally available. We've launched, as I mentioned, we've gone from hundreds to thousands of cloud providers in the Pulumi ecosystem in the registry. We launched significant improvement to our Kubernetes operator, which we call 2.0, which allows you to actually orchestrate Pulumi deployments from within Kubernetes clusters using CRDs. We shipped a new EKS provider for best-in-class support for AWS EKS. And we dramatically improved GitLab support in the product. So if you're using GitLab for source control and CI/CD, Pulumi Cloud is going to feel that much more natural. We brought AI and the best of large language models to your infrastructure. That started with Pulumi Copilot that was shipped last year that allows you to generate infrastructure as code, but more than that, gain insights into your cloud infrastructure and ask questions from very basic ones like, where is IP address 1.2.3.4 to what is my most expensive, least used resource. We brought that into Visual Studio Code, so you can have Copilot sitting there with the context of your full application code. And more recently launched a Model Context Protocol server, MCP server, which allows Pulumi to plug into your favorite vibe coding tools, including Claude Code, Windsurf, Cursor, VS Code, and a growing array of tools that support MCP. We also launched new products. We launched ESC, which stands for Environment, Secrets, and Config. This is Pulumi's approach for how you manage secrets and configuration at scale, both for applications and for infrastructure. We've recently improved that with secrets rotation so that if you have static long-lived secrets, you can rotate them. Of course, we prefer dynamic short-lived secrets, and we've made those even easier to use as well. It includes Pulumi Insights as well, which is a really exciting new product. A lot of our customers are very excited about that. Really, this is basically like turning on a flashlight in a dark room and suddenly seeing all the cloud resources you have sitting everywhere. We'll give a complete audit inventory of everything that you've got in your cloud estate across AWS, Azure, Kubernetes, any cloud. We'll give it to you in a easy to consume form so you can see what you've got, slice and dice it, search it, ask questions using Copilot. And we've also added the ability to run policy enforcement across all of your existing resources. And with that, we've actually crossed recently 3,500 customers, which is an amazing milestone. So thank you to every one of our customers that I know are in the audience today. These customer case studies, which you'll hear a few of the stories today, span some incredible success stories. You know, the things that folks have been able to build with Pulumi that they couldn't have otherwise are just game-changing for their businesses. That includes Snowflake innovating with their data cloud and rapidly incorporating AI capabilities into their own product. NVIDIA, who's managing some of the largest GPU-loaded clusters known to the planet. Moderna, who is radically innovating in vaccine development and R&D, and able to empower their data scientists to really tap into the cloud to save human lives, literally. And BMW, who's reimagining the modern car in a cloud-first era. And with that, I'd like to welcome a customer to tell us a little bit about how Pulumi has changed their lives. So introducing Daniel Kisselman, DevOps tech lead at XM Cyber.
I'm working at XM Cyber. We're based in Israel, in Tel Aviv. Okay. The company was founded in 2016, and we've been running for almost 10 years now. We are part of Schwarz Group. It's a big retail company based in Germany. We run multi-cloud. We support AWS. We will support soon GCP. And also we support Stack IT, which is a European cloud provider, which is developed by Schwarz Group. We seeked a new solution. We seeked something that can give us enough agility and can give us the solution we need for those scenarios. And Pulumi came in rescue. First, we started writing in Node.js, in TypeScript, our Pulumi programs. And then as our team grew, we moved to Python, and we're writing Pulumi ever since in Python, and we're loving every minute of it. We actually took it, I think, to the next level by leveraging the Python packaging. We have actually some plans in the future to create an actual developer platform and use it. And of course, Pulumi will be the backbone of this.
Well, that was great. We heard how XM Cyber has successfully used Pulumi to codify their infrastructure abstractions using Python. And you heard Daniel say they've been loving every moment of it. And that's something we hear a lot from our end users. We like to say Pulumi is the cloud infrastructure platform that engineers love and enterprises trust. And that love part is very important to us. That's where we started. With Infrastructure as Code, our open source tool, we really put every thought into every little detail of making sure the end user experience was amazing and productive and felt fun to use. But we know that's not enough. We need to marry that with a platform that enterprises trust. And that's why a lot of the capabilities that I highlighted that we've been working on over the last year are very important. They brought security, governance, compliance, robust enterprise level controls so that you can love using the tool, but you can also adopt it at vast enterprise scale. So that's what we've been up to. Let's now talk about what's new. Today, I'm super excited to announce 3 major additions to the Pulumi platform. The first is Visual IaC Import. Using Visual IaC Import, you can bring existing cloud infrastructure under the management of Pulumi IaC. You simply point Pulumi at your existing cloud accounts. We'll tell you what's there. You can filter and group and select things. We'll even discover related resources and dependencies that you might not know about. And then with a few clicks of a button, you can generate code in your favorite programming language, and even use AI enhancement to improve the code, whether that's stylistic, making it more in the style that your organization uses, or just cleaning up names and formatting. From there, you can download the code, add it to an existing project, or create a new one, and import the state. And from there forward, Pulumi is managing your infrastructure. With a few clicks of a button, you've gone from chaos to complete IaC management and automation. So we're really excited about Visual IaC Import. The second capability is the private registry. Just like the Pulumi public registry, the private registry gives you one single source of truth for a set of building blocks within your organization. That includes components, templates, policies, and documentation for all of them. Using the private registry, you can manage the artifact lifecycle, including semantic versioning for all of your building blocks. You can gain organizational insights into how your team is using the various building blocks in the registry, and enable easy sharing, discovery, and reuse of the patterns and practices you'd like to use within your team. And third is Pulumi IDP, an entirely new product to add to the Pulumi family. IDP stands for Internal Developer Platform, something many of you are very familiar with. And what Pulumi IDP does is takes all of the amazing building blocks, all of the amazing capabilities we've been talking about, and wraps it up in an IDP product. That includes giving you the ability to codify and enforce organizational standards as a platform team, including components, templates, policies, leveraging the private registry. It allows then end users of the IDP to flexibly spin up and manage infrastructure with built-in guardrails. These end users can, of course, be developers, data scientists, or anybody in the organization that wants an easy way to provision and manage their infrastructure. When I say flexible, there are many ways you can consume the IDP. The first is full no-code. In this mode, you can click in a UI to spin up the infrastructure, configure it, redeploy it, without ever having to know that it's powered by IaC under the covers. There's low code, which is the ability to configure infrastructure abstractions using YAML and deploy it using CI/CD pipelines, Kubernetes operators, or any tooling of your choice. Then, of course, there's full code. Many organizations actually want their IDP end users to be using IaC, but in this case, they can use different languages than the platform team has chosen to use. Maybe the platform team has created their components and templates in Python, and end user developers are using TypeScript to consume them. And finally, everything with IDP in true Pulumi fashion has a REST API. And so it's fully extensible, customizable, and can integrate with your custom tools and workflows. Pulumi IDP doesn't stop on day 1 and 2, however. It goes well beyond that. You can detect and remediate policy violations, drift detection as well. You can perform change management as you roll out new components and templates and understand who's using what in the organization and ensure that things are always compliant, always secure, and you can find issues before performing your rollouts. And then finally, we're launching Pulumi Identity and Access Management, IAM, which is the next evolution of the Pulumi security model that builds on top of our identity and RBAC model and extends it with custom policies, roles, and attachments for the entire set of building blocks in Pulumi IDP. So those are the 3 announcements. Let's dive into some demos. To tee this up, we're going to have a little bit of fun, a little bit of role playing. We're going to pretend that we are an engineering team at Initech, and we're going to set up a platform, and we're going to do it real time and show you how to do it with Pulumi IDP and Registry and everything we've already seen today. I'm going to kick us off, pretending I'm the CTO at Initech, trying to get a lay of the land and understand what this is going to entail. Then Komal, who's an engineering manager at Pulumi, will play the role of the platform engineer, and Megan, who is general manager of IaC here at Pulumi, is going to play the role of software developer at Initech. It's a little bit fun, but hopefully informative. And to set the stage even further, this is a common situation in organizations that we work with who are going through a moment of change where the cloud has become the bottleneck or they're not able to move fast enough. Especially today in this AI-fueled era where we've got to ship code faster than ever before. It's got to run in the cloud. It's massively distributed. Everything is just moving so much faster. And the organization needs to be set up to support that speed. And yet, we know security is paramount. We can't be suffering security and governance issues. So the conundrum is, how do we move fast with built-in guardrails so that we have that security and governance assurance that something's not going to go wrong? And so our CIO here at Initech has passed down a set of requirements. We've got to have full visibility and control into everything we do. We've got to make sure that nothing violates the policy, that everything is secure and governed, that risky changes are approved by the right people, that we're using the principle of least access. Everything's got to be automated and reusable, so we're not copy and pasting, that we're actually using patterns and practices that the security team can review and sign off on. No manual changes, and developers need to be in the driver's seat. They need to have a great developer experience. They need to be efficient. The only way to move at the speed of modern business, especially in the AI-first era, is to let developers ship code faster than ever before. And so we're going to get all this done in the next few minutes. And I'm going to get started. Let's dive in and see what we're dealing with.
Okay, before Kamal builds out our platform and Megan uses it for developer self-service, I'd like to see what we're starting with. Most folks coming to Pulumi would start with the infrastructure as code CLI, but we've already got a lot of legacy tech debt. So I'm going to start in the Pulumi Cloud Console. You can see that my team is already signed up and is already deploying things and spinning up resources. But we're going to head on over to Pulumi Insights, where we can get a quick view into the state of our existing cloud accounts. The dev sandbox is already hooked up, but we're going to go ahead and create a new account, select AWS, and we're going to take a look at the Initech staging environment, where I know we've got some resources that need to be cleaned up. Kamal has already set up an IaC environment for us, so we can quickly authenticate using short-lived OIDC dynamic credentials. We're going to click Create after selecting all the regions, and a scan has already been kicked off. Pulumi Insights is now discovering all of the resources that already exist, no matter how they were provisioned. With Pulumi, Terraform, CloudFormation, manually pointing and clicking in the console, we don't really care. And we can see that resources are starting to show up. They'll incrementally load as we go. Let's head to the resources page, where we can now see the details of all of the resources being discovered. We can group by properties like the category and type to easily understand what we have in our account. For example, we can see here we have 936 S3 buckets. We can also drill into the details. We can group by other more interesting properties too, like when was the resource last modified. We can now see in the last 24 hours, we've had 96 resources that have been modified and over 3,000 resources that haven't been modified in over a year, probably indicating cloud waste. Next, let's check out the policy violations page. This shows us which resources are violating policies, even for resources not yet managed by Pulumi. We can filter by account to see that we've already discovered new policy violations in the account we just began scanning, including an ECS task that's consuming too much memory. Or we can just take a holistic view at all the violations across all of our accounts with grouping and sorting. We can see here we've got a lot of issues with tagging. In our organization, we require department tags so we can always know who owns what infrastructure. Let's go ahead and fix some of these violations. First, we're going to get it into Pulumi IaC. To do that, we'll use the new Visual Import tool that we just launched today. Go over to the Import tab, and then type in a search to filter down to the resources that you wish to import. Here, we're actually using natural language to find all of the resources owned by Milton. There's only 2, but they seem to be missing the other department tag, which is required. We'll select them, click Next. Pulumi will infer all of the related resources that we might actually want to import, but for now, we'll deselect them and stick with just these 2. We can see here it's generated the code. We prefer Python, so we'll select that. This clearly is auto-generated code. I think it can be nicer. We'll click Enhance to use AI to automatically comment and make sure the code is clean. And then from there, we can copy the code and head on over to VS Code. We'll import these resources into a brand new Pulumi project. We run the Pulumi new command to scaffold a bare bones AWS Python project. It'll install all the dependencies. We can go paste the generated code into the main.py. We want to deploy to the US West 2 region, so we'll set that up now. Kamal has already conveniently set up an IaC environment that we can use for short-lived OIDC AWS credentials. Let's check out the code briefly. You'll see these import statements, which tells Pulumi to import the resources rather than creating new ones. You'll also see we get great statement completion, including Copilot in red squiggles when we make a mistake. This is going to be a massive productivity win for the entire team. Now let's drop down and run PulumiUP to perform the import of the resources. This doesn't modify the state of any of our cloud infrastructure. It just brings it under the management of Pulumi IaC, so that from this point forward, it's IaC managed. Now for those pesky policy violations. Pulumi's new MCP server integrates with many AI tools, including GitHub Copilot right here in VS Code. We're going to ask it, do we have any policy violations? It's going to run Pulumi and find them. And then it can help us actually fix them. We'll ask it, yes, please fix these violations that you found. We'll also tell it what our department should be. We're late on our TPS reports, but we're in that department, so we'll tell it to tag it TPS reports. And Copilot goes through and actually edits the code, adding the missing tags. Then it deploys the changes. So right now, it's actually patching our infrastructure and adding the missing tags, and now we're fully in compliance. Now for one last task. It's a real shame we've got all of these ad hoc resources everywhere with mistakes and lacking the best practices. I wonder if we can use the Pulumi component model to start cleaning some of this up. We'll ask AI to help us with this too. We'll tell it to refactor our cluster and service into a component so it's easy to remember to include best practices like tagging. And what do you know? It's gone through, refactored the code, derived from the Pulumi component resource. But this is just scratching the surface. There's so much more we need to do.
All right. Well, slightly chaotic mess, but I think we have a path forward. So what did we see? Just a quick recap. We saw that we could get full visibility into everything that we've got in the cloud already before even adopting Pulumi IaC or IDP using Pulumi Insights. We quickly identified that we had resources that were violating our policies. We easily imported those resources into Pulumi IaC using the new Visual Import capabilities. And from there, we were able to use the great tooling support with VS Code, our policy extension, and some AI assist to fix the policy violations and remediate them, and refactor the code and get it ready for our new platform. But we're not stopping there. I'm an amateur. It's time to bring in the experts.
Thanks, Joe. Hello, everyone. My name is Komal, and I'm a platform engineer here at Initech. As a platform engineer, my focus is making infrastructure self-service, secure, and cost-efficient so development teams can ship features fast without getting bogged down in ops. Today, I'll show you how to create a secure, cost-controlled infrastructure component, publish it to our private registry, wrap it in a turnkey template, and safeguard it with policy as code. Let's get started. One of the basic building blocks of infrastructure for the development teams at Initech is the trusty containerized application. It's such a useful pattern, but has quite a few moving pieces that our developers shouldn't have to worry about. So let's talk through it. Over here in my IDE, I have my component defined in Python. This file has nearly 400 lines of infrastructure code and includes resources like a private VPC, subnets, security groups, all of the ECS resources, secrets and secret manager, and ALB, etc. All of this is important to make sure our applications stay secure, but that's definitely a lot more infra code than our developers want to keep track of. So instead, we've exposed a very simple interface to our component, narrowing it down to just the things that are important to our developers, like where the application is located, what port it's running on, environment variables and secrets, and some tags for the resources. Now, to publish this command, all I need to do is run Pulumi package publish and pass in the URL of where the code is stored in source control. In my case, I'll pass it a GitHub token, since this is a private GitHub repo, point it to a README, and pass in the name of my org as the publisher. Now, let's pop over to the Pulumi Cloud UI to see what this looks like in the console. We'll pop over to the new Components tab, where I can see all of the components that are published to Initech's private registry. Let's click in to Container App, since that's the component we just published. In the README here, we have instructions for how this component can be consumed, code samples for how to use this component in Python and YAML, but of course, this component can be consumed in any supported Pulumi language. And down here, we have the API docs, including all of the inputs and outputs of the component, their types, and their descriptions. Okay, great. Now we have a container app component. It can be easily initiated with just a few inputs, and our developers can use it to deploy any of their apps. I think we can make this even easier, though. I've noticed a lot of our teams spinning up AI chatbots that use a pretty standard pattern and all need access to an OpenAI API key. So we can wrap this component we made into a template, providing the developers with some standard boilerplate code to get started. Let's head back to the IDE. I'm going to navigate over to the template directory where we consume the component that we defined earlier. So that's this chatbot container app TS directory here. This is the infrastructure file. And you can see the complexity of 400 lines of infrastructure has been transformed into the sweet simplicity of these 27 lines. You might also note that this file is in TypeScript, since I can consume the component in any language Pulumi supports. Most of this file just lets the template direct configuration directly to the component, but there are a couple of specific things I want to point out. We have a system prompt here that lets the user define a custom system prompt to pass to the application, to include with every API request. Another thing I want to point out, we're passing in an OpenAI API key so the application can connect to OpenAI. Now, let's pop over to the app directory, which contains some starter application code. Here you can see the system prompt being read in and passed to the API. The benefit of a template is that I can wrap up all of this boilerplate code alongside the component so the developers have everything they need to get started right away. Let's pop over to the UI again to see what this looks like. Now I'm in the templates directory in the templates tab of the Cloud UI. These are all of the private templates that are available to the InnoTech organization. Let's take a look at Chatbot Container App TS, the template we defined earlier. Here, we have the README for the template, once again, including the installation instructions. In this case, all I have to do is run Pulumi new followed by the source URL. Once again, I'm passing in the GitHub token because this is in a private GitHub repo. There's some other information here, like the configuration and outputs available from the template. All right, now let's talk about secrets. Our template needs AWS credentials and an OpenAI API key. We already have a couple of ESC environments set up that contain those keys. We have the OpenAI environment that contains the API key, alongside the Dev Sandbox environment that uses OIDC to generate dynamic credentials to access our AWS accounts. Now, the common chatbot secrets environment imports the two environments that we just mentioned, merging them together to create the exact shape of configuration that we need for our template. It has the environment variables for AWS credentials and the OpenAI API key set as Pulumi configuration. Lastly, let's talk about compliance and cost controls. We want our developers to have flexibility, but we need to make sure our costs don't balloon out of control. So we've deployed a policy pack that lets us configure some policies like required tags and max values on certain properties. We'll head back to the IDE to show you the code for this policy pack. Our policy pack is configurable. It has two policies, one that allows configuring some required tags for our resources, and another one that lets us set limits on CPU and memory for our ECS tasks. Note that the limits are not set here. Those are configurable in the UI, which I'll show next. Here we can see that this policy group uses the policy pack from the code, but this is where we've configured the actual policies. So we've required that our resources include the department tag, and we've set a max limit for memory for the ECS services so we can be alerted if any services exceeding that memory limit are deployed. The flexibility of configurable policy means I can set different limits for different stacks, since I might want my production stack to have a higher limit than those in development. And that about wraps it up. At InnoTech, we've shaped our internal developer platform around our top priorities: speed, cost control, and strong security posture. Because Pulumi exposes every layer as code, we can encode those priorities directly into the platform's building blocks, giving developers guardrailed self-service without sacrificing what matters to us. And there you have it. We've turned a complex ECS containerized application into a single reusable Pulumi component, wrapped it in a template, and safeguarded it with policy as code. Now I'll hand it back to Joe to kick off the next demo.
Thank you so much, Kamal. That was amazing. Let's recap what we saw. We saw capturing our team's best practices using a reusable component written in Python, creating a template for new projects so that it's easy to access those components from the IDP. We defined policies to enforce governance, ensured full automation and full security of everything that our team is doing. And we configured our team's IDP so that it's ready to go. And next up, we're going to see that IDP in action. Welcome, Megan.
Thanks, Joe. Hi, everyone. I'm Megan, a software engineer on the Initech development team. Today, I'm going to show you how to go from zero to a full policy compliance service using the Pulumi IDP. Now let's dive in. Today, we're going to deploy an AI assistant for our public website using the chatbot container app component that Komal just wrote. First, we're going to do so from the UI without touching any code, and then from our IDE using Pulumi code. So I'm starting in the Pulumi console. The first thing I want to do is under Pulumi IDP, click Templates and filter it for my use case. So I'm going to go ahead and do that, and I'm going to scan what our best practice abstractions are and pick the chatbot container app because that's the one that makes most sense for our use case. I'm going to read through the README and try and understand if it achieves my objectives, like having the OpenAI API key. Okay, this looks exactly like what I need. Let's deploy it. Now, jumping in here, we want to change the project name to the public website chatbot app, and I'll paste in here a description for our project. I want to keep the stack name as dev, and I'm going to select the deployment method here. Now, the no-code deployment means that Pulumi Cloud manages the code, and all I have to do is update the configuration from the UI. The get backed one will just point us at the branch, and the CLI deployment I can just do locally. Next, looking at the right-hand panel, I'm just going to type my name in the owner in our configuration panel here, and I'm going to paste in a system prompt that will make this tuned to be our public website AI bot. So it's going to answer questions about the company and its products. And the last thing I have to do is grab our secrets in our IaC environment, which has both our application secrets and our infrastructure configuration details. So now that that's deployed, I think I'm going to go and stamp out a staging stack while I'm waiting for this to deploy, because it does have a container in it and it will take a while to get going. So I navigate to the project page and add a stack. So as you can see here, it's quite easy to be able to just stamp out the different instantiations of each template. And then all I have to do is add this metadata in my configuration values. I can also update this metadata if I wanted to, let's say day 2, change something about the prompt or tweak it. I can edit that from Pulumi Cloud. Now let's jump into the IDE. Here in the IDE, you'll find a Pulumi YAML program. And in this program, we're referencing the same component that we were deploying from the UI. So you can see here the properties, similar to what was in the UI. And these are the ones that I thought were most relevant, so I had them in here. And if we look in our app.py file, you'll see that I moved the system prompt into the Python file as I'm locally developing and just wanting to run the Python file. Now, I've asked AI how I can increase memory to make this handle the scale of our public website. And so I just said to the inbuilt LLM in Cursor, which is Claude, in this case, hey, how do I make this scale to be massive? And it's gone ahead and said, all right, you want to increase your memory to 8,192. I run a PulumiUP on this, and we should be up and away. Oh, but it looks like actually we hit some policy violations, and they're just advisory, but if I went to do this in production, it would be mandatory and I wouldn't be able to deploy. So the first thing is we're missing the required tag department. Right. I forgot about that. Cursor helps me out here and auto populates it for me. But our platform team requires this so that they can do cost tracking in our organization. So everything needs to be tagged with it. The second policy violation we have here is that the ECS test is taking too much memory. And so we have an upper limit of 4,096. So let's just paste that in and stick with what our platform team recommends as the maximum we use. So let's go ahead, run a PulumiUP again. and see if now we can get a clean deployment. And so as you can tell, I've used AI for this, and I've been able to move quickly, but also stay within the guardrails of our policy. Now, while we're waiting for this to deploy, because it will take a bit, let's go and test the endpoint that we just created from the UI, because that should be up and running now. So I'm just going to paste in a curl command that I've written that references the URL from our last container at the chat endpoint. And so I'm asking it, what can you tell me about your company to test that it got the prompt correctly and it's ready to be used by our front-end code. And so you can see that it's talking about Initech code. So everything's working as expected, and it explains what our company does. And so now we'll be able to reference this. We'll be able to use this endpoint in our front-end code, and the service is up and running. And we've done it from both the UI, but also from inside code, and been able to find success here. So the last thing that I wanted to show is going back to Pulumi Cloud, our concept of a service. And so in a service, you can have, it's a container for all of your entities within Pulumi. So in this case, I would probably want the stack we're looking at. I would probably also want the environment we use, so I have all the configuration and secrets. And you'll find the services under the left-hand navigation under Pulumi IDP. Now, other types of things that you can put in this container is your links to things, and you can even have like documentation and strings for any customization on what you might want to tag them with. But so on the right-hand side, you can see we've added our app URL. You can see when the project was created, the description for it, and that I'm the owner. And this will now be my dashboard for me as an application developer coming into Pulumi. I'll just want one page where I can see all the helpful information. And one of those things is my ECS metrics dashboard, which I'm going to want to be able to keep an eye on how my cluster is doing now that it's live and see what the utilization is, make sure that it's healthy. And so I have this all as one single source of truth, one place that I can go and get all of the reference material for my project.
And there you have it. Self-serve, no-code stacks that I can either click to deploy or eject into code and customize. We benefited from the speed of having reusable infrastructure patterns ready out of the box, but we were able to stay compliant with the policy guardrails. Now I'm going to hand it back to Joe, who's going to wrap up what we've learned today.
Thank you, Megan. It's amazing seeing Pulumi IDP in action. Let's recap what we saw. We saw that we were able to create a Pulumi IDP service that holds all of my application's building block entities that were defined in the Pulumi registry. We deployed cloud infrastructure with no code, low code, full code. We were able to easily reconfigure and redeploy and benefit from built-in guardrails and governance. And at the end of the day, developers are self-serve, productive, and still secure. And I think we're going to make that CIO happy. So with that, just a quick recap of the Pulumi IDP core concepts. Services are sort of containers of all the building blocks that your IDP end users are spinning up, managing. It's one place to go to collect all of them together. You've got components, which are the infrastructure abstractions powering everything behind the scenes with Pulumi's very powerful infrastructure as code engine. There are templates, which are blueprints to scaffold new projects. Policies, which cross-cut all of the above and ensure that you're following your organization's best practices at all times. You've got a self-service portal where you can see what's available to you and what's up and running. You've got Pulumi IAM to make sure that you've got rich, secure controls over all of those building blocks. The ability to include links to observability dashboards and approvals to make sure that we're able to empower the right people, but with the right guardrails and right checks and balances in place. And although Pulumi IDP works great out of the box and you can get up and running with the platform in a day rather than a year, we still love our building blocks here at Pulumi. Everything we do is customizable, extensible. We've got a rich data model and REST APIs, so you can program your IDP the way that you need to. It can integrate with what you already have if you have custom integrations and backend systems, CI/CD pipelines, etc. It also integrates with other portals if you have Backstage or custom UIs. We, in fact, have a custom reference architecture that we've put up on GitHub that's open source for you to check out if you want to see how that might work. And the result is a fourth addition to Pulumi's product portfolio. And of course, as with every product, each of these is independently adoptable, independent of the other, but work better together and share the common REST API security model, data model, and capabilities like Copilot, CrossGuard, and Workflow. And everything we've shared with you today has been informed by real-world IDPs that we're seeing our customers build, like Clear. James Forcier here at Clear is a staff engineer, and he'd like to share with you how Pulumi has helped them build their IDP at Clear.
I think our usage of Pulumi kind of falls into two categories. One is just the base like IaC tooling that we provide to production engineering to build, whatever custom IaC tooling they need for very specific use cases. But something that we spent a lot of time on as well is essentially just what you described, an internal developer platform where instead of having, our centralized infrastructure repos where there's huge blobs of Terraform that developers have to maintain and care about, we move those configurations into the service repos themselves, which is a big win for our developers, right? They don't have to go hunting around in multiple places to find where their infrastructure is defined. It's just right there in the service code. And we also moved from a sort of lower level Terraform and HCL based interface to something built with Pulumi. We're looking at condensing what is about 150,000 lines of HCL down to probably an order of magnitude smaller in terms of both code and config in Pulumi. Right off the bat, having just less to manage there, and in particular, less for our service teams to manage, right? A lot of that 150,000 lines is service infrastructure that's not directly owned by us. And that's a huge burden for service teams to have to manage a lot of HCL and infrastructure code that isn't really in their day-to-day sort of wheelhouse. So being able to consolidate that down to something that's a lot easier to manage and audit and review as well is a huge benefit.
So you've heard from James there how using Pulumi to build out their IDP enabled them to put developers in the driver's seat and accelerate innovation while still having the confidence and compliance that they need. Pulumi really helps to unite the entire software engineering team, starting with the platform team, allowing them to define their best practices, review them with the security experts, and make sure that they are secure and compliant and staying up to date as they need to, and then going and empowering developers to be self-serve and innovate faster. And that's a wrap. That's everything we've got to share today. We're really excited about Visual IaC Import, the private registry, and Pulumi IDP. If you'd like to try out anything you've seen today, go to pulumi.com. Of course, it's free to get started. And most of what you've seen today is live today, and anything that's not there will be coming out in the coming days and weeks. And I'd like to extend a sincere thank you to our customers and partners. Without you, today would not have been possible. That includes AWS, Docker, GitLab, Honeycomb, and Temporal. Also, we're launching a new platform engineering workshop series that's beginning tomorrow and extending throughout the spring. So please join that if you'd like to understand how to use Pulumi for platform engineering, including building IDPs. And that's it from me. We've still got some exciting customer talks and panels throughout the day that I hope you enjoy. Thank you for joining PulumiUP 2025. Can't wait to see you next year.
Motive care started as a lot of different disconnected parts, a lot of different organizations, and what we've been trying to do organizationally from a top down is try and find that streamline one way of doing things. We started to leverage Pulumi Insights to solve for the folks that wanted to get expression and visibility of their cloud on things that weren't necessarily managed by infrastructure as code in the first place, and being able to then see quickly with Insights what portion of resources are scanned versus what portion of resources are expressed as an infrastructure as code process. And number two, Pulumi IaC has been fundamentally game changing in how we want to bring that apart, not just in solving that disconnected set of Terragon files, but also in normalizing a lot of those Terragon files. So we've been leveraging both in relation to infrastructure as code quite a bit. We're pretty all in on the whole IaC capability. So we're doing mostly configuration, but we also are leveraging the OIDC connectors to our AWS accounts. So we're, as part of that our organization being a product of many organizations, the AWS organization itself is a little bit disjointed, where, we had an organization, we had a top-down design, there was an acquisition, they were in AWS, that account got added to the organization after the fact, and there's, some nice abilities to quickly basically jump across accounts with OIDC being able to provide that access layer.
Welcome, everybody. Welcome to PulumiUP. Welcome to our panel discussion, From Infrastructure Engineering to Platform Engineering. I'm your moderator, Josh Kodroff. I am a Principal Customer Success Architect here at Pulumi. I've been with the company for about 3.5 years, and I've seen just about every different way you can use Pulumi. Today, we have some Pulumi customers with us that are going to share their platform engineering advice and expertise. So let's start with some introductions.
So my name is James. I'm a staff engineer on our infrastructure team here at Clear. And you may have seen us in the airports with our expedited security lanes there, but here at Clear, we're also building sort of digital identity as a broader platform for everything, whether that's renting tools at the hardware store or getting into the stadium faster at sporting events. So I work with our infrastructure team as well as our developer experience team and a handful of other teams within production engineering to sort of build out our as we say, internal developer platform, right? So whether that's engineers provisioning their infrastructure or, how services connect to each other from the networking perspective, I'm sort of working across teams to help build all of that.
My name is Zach Cook. I'm a senior DevOps manager here at MotiveCare. And over this last year or so, we've built a kind of a cloud native or a cloud platform engineering team to sort of help drive a lot of transformation here at MotiveCare. So MotiveCare is a product of several years of acquisition, several years of different pockets of kind of things. And so as a result, our landscape had started pretty dynamic. There was a lot of really good cloud native engineering. There's a lot of brick and mortar rack and stack stuff. And kind of our guiding light has been how to normalize that and meet basically every team where it lives today versus where needs to go. Basically building as much acceleration as possible without mandating migrations to a single set of tools or anything like that.
So my name is Simon. I'm the founder of Sockle, a really early stage startup. I've used Pulumi for, I think it was 2018 or 19 for the first time. And also worked for a company called Björk for a very, very long time, doing platform engineering. And my background is engineering, and so my role in most of these companies has been to build the platforms and support the team essentially.
Okay, so let's start with what exactly platform engineering means to each of you. Like, platform engineering can mean a lot of different things depending on the org, depending on the context. What do you feel are the essential ingredients of platform engineering as a practice? James, you want to start?
Sure. Yeah. I think to me, the most important sort of component is identifying the common tooling and resources and solutions that your engineering teams need, and making the road for those really well paved. So building out essentially a really polished and easy to use toolkit of solutions that engineers can reach for really easily, so that they're not blocked on infrastructure or other sorts of solutions on that side, trying to actually, solve business problems. So I think a big part of that for us is identifying what those really commonly used patterns are, making them really easy to use, and then also sort of anticipating where things will go next, right? So we don't want developers to come to us with necessarily with feature requests that they need today, they're blocked on, that sort of thing. So trying to have an idea of, where can we grow support in the platform for new features that we think people will need going forward is kind of an important balance to strike.
Interesting. What was the situation like at Clear before there was like a concerted platform effort? Like, did you have to use stick as well as carrot in terms of narrowing the list of tools that developers were able to use?
Yeah, I think that's a fair way to put it. I think previously, we'd had a focus on providing sort of lower level tools, taking that maybe what I would call a more traditional DevOps approach of saying, we want teams to own their infrastructure end to end. So we're going to provide a really low level suite of tools that they can use to build whatever it is that they need. I think we found that caused a lot of friction, and it caused our engineering teams to spend a lot of time fighting with those low level tools rather than actually solving the problems that they're trying to solve. So what we've tried to do to move away from that is to say, okay, what are the common use cases here? Let's try and make those really, really easy to use and get people to enjoy using the products that we put out, so that hopefully in the future we can move to more of a scenario where people want to use our tools because they have a good experience with them. We have a track record of, providing the features that they need out of the box, or, before they know they need them, right?
I think maybe a little bit biased from coming from like a heavily compliance driven initiative, right? But there's absolutely the governance and compliance aspects that are baked into it. I think fundamentally platform engineering offers acceleration, right? That's the big deal. So coming into kind of an older organization, there's real-time measurements of, if I want to get a change made or I want to get a piece of architecture stood up, that might involve having a ticket, having a traditional IT response that's measured in days to weeks, as far as depending on how complex the change is, and then delivering something where I think our guiding light, our story that we're trying to tell is that we'd really like to get to a place where there is a day one engineer that is hired. They're hired in the morning, and then they actually have their first production deployment by lunch, and we celebrate as an office, like as a thing. And we'd like to really get it to where all of the compliance and all of everything that makes that deployment possible are in the platform. That's part of what the platform engineering is bringing to the table, is that all that compliance is there, but it's the best kind because it feels invisible to the end user.
I think if we can also look at this in a little bit more abstract way. I think the way that you should look at it is as a internal digital product more than just some technical solution, right? So and the goal of platform engineering is essentially to move the complexity, right? So you can reduce the mental weight of a developer, so that they can, understand what they need to understand in order to get productive and quick, as Zach said, right? So, and those, it's really important to remember that as a core thing for at least for the product to work, I guess, or the concept to work internally.
So let's talk about the role of infrastructure as code in platforms. It's kind of the straw that stirs the drink, to use an expression. So beyond the obvious case for cloud infrastructure resources, are you managing anything else with infrastructure as code that enables your app teams to move faster?
We began using GitHub, right? We not just using AWS or GCP resources, but we were using the GitHub provider as well, which was a really good start. It was just simple stuff in the beginning with, setting up GitHub action secrets and stuff like that. But in the end, we've now, I think we provision access to repositories. We have really used it in detail there, and expanded also to secrets, right? With Pulumi IaC, and now also giving it into the command line as well, and on the local environment. And that's where sort of everything comes together, at least in our team. Yeah, I think you could start with the Kubernetes thing, because that's one of the things that I really found interesting, because we've been passing around, if you use GCP, you have to have the G-Cloud command line, right? And that is sort of your authentication toolchain for your Kubernetes engine. So what we did was that we have exposed the kube config environment variable. So it's available for you in the command line, which makes it so much easier for people to jump between the environments. That's one thing. But what we also ended up doing is that we were able to create much smaller applications, or you could say Pulumi projects, based on using the kube configuration, and have that inherited through and imported, you could say, in the different IaC configs. It was a really valuable little thing, but it was really valuable for us.
Yeah, that's one of my favorite use cases for IaC, is actually Kubernetes cluster access, because it combines like two things in IaC. So both typically you're using OIDC credentials, and then you're going to use an import and then bring in the kube config on top of that, and that's like gives you really convenient temporary access to clusters. That's awesome. Okay. James or Zachary, do you want to chime in on Pulumi, the general languages approach, how you're leveraging those features, or ESC or insights?
Yeah, I can talk a little bit about it. I think for us, the general purpose programming language, excuse me, aspect is really attractive because it makes it possible to tie together resources in a way that maybe you can't with something that's a DSL like HCL. One of the big things that I think is helpful there as well is the ability to call out to things that may not have providers implemented for them, integrate with things a little bit more flexibly, right? So obviously, if there's not a provider available for something and you just need to fetch a couple of data values, it's really easy to use your standard programming language facilities to, in our case, one of the applications there is, fetching various bits of metadata about what teams are valid, that sort of thing, so that we can do a little bit of extra validation, make sure that everything's integrated in the same place that we expect it to be. And so I think having that flexibility to, call out to external sources a little bit more easily, and, do more complex transformations on resources to tie things together. So whether that's automatically generating Datadog monitors for resources that recreate, right? That sort of thing, I think, is a lot easier to do when you have the full power of general purpose programming languages available.
I just really appreciate the general language model because as somebody who has a bit of a programming background as well as an infrastructure background, one of the biggest frustrations I had with most modern infrastructure, most DevOps, is just how much time I spend hand editing YAML files and things of that nature. And I really feel like that should be something that's generated for me rather than something that I edit. I love to be able to review it, but I really hate working with it. so I like that Pulumi kind of blends that in, and then you still get something that's ultimately, at the end of the day, a declarative thing, but it's generated with languages. It's really, really nice, kind of a nice hybrid. Beyond just the normal infrastructure as code, as normal as far as cloud computing, we have leveraged some of the providers as well. It's kind of a similar thing, setting up our Git repos in a certain way, or reaching out and creating Datadog things. Policy as code has helped to get some leverage as well because it extends into the provider models. So we might have something where we need a certain tag or anything like that. And all of a sudden we now have this platform that gives us the ability to govern that across multiple providers. We don't need to figure out how to do a tag policy in each of these different platforms. So that's been really nice to kind of bring it together where we can start to boil things down to, if it's done with Pulumi, we have this policy engine behind it. We have the standardization right there. It gives a lot of pathways that weren't there previously, which is nice.
All right, so let's move on to self-service and golden paths. Tell me about your organization's journey in platform engineering. What were the motivations for starting a team?
The initial takeaway was that we wanted something that was going to be a single place, a single source of, or a single pane of glass where all these different integrations through all these different acquisitions and so forth could look the same. So we had, I expect, a fairly common problem of companies that have come together from acquisition where just because we had source control everywhere, we didn't necessarily have the same source control. We bought this company that had GitHub, and then this company was using GitLab, and you can take an initiative and say, okay, everyone's in GitLab by the end of the year, but in the meantime, you're trying to give value, trying to give what software exists in GitHub and exists in GitLab. How do I track this kind of initiative? So just general categorization and cataloging was a fundamental need. And so that we're using Backstage for our IDP, and that was the day one initiative was let's just figure out where everything even lives and try and get a way to get it in there, and then we'll start to measure it. From there, we shot right for the golden path. Let's get a create scaffolder that does a fully loaded pipeline with all of our best practices.
I'd like to know if anybody wants to chime in on how do you figure out the right things to build and what things to either not build or not build right now into your platform?
I could go through a little bit of our, story there, because we started off building a lot of, you could say, components and modules, you could probably call them. And we imagine that it would be a lot easier for everyone in the different teams to work with it. But what we learned early on was that it's actually the most basic things that are the most used, because we weren't able to fit find exact resources and modules to build that fit the real needs, right? So, and we also weren't able to create great documentation fairly easily. So at some point we ended up using more of the native features of Pulumi and just expose that to people, and then ask people to create more, you get smaller Pulumi projects, and then you can hook on the bigger resources instead.
So maybe we could also talk about like what is the application team's experience using your platform today, and if there is a gap between what you have today and your ideal state, what would the ideal state look like?
Platform we have today is about a year old, so it is still somewhat immature in that sense. So today it looks like it's a very like purpose specific thing. If I need to create something new, and a software engineer might think to go to the platform. If there's documentation that might still be in some Confluence doc, or like there's all these existing patterns that have lived here for a number of years that people are just accustomed to. So what we're kind of looking to, and what that future state is we're trying to find small journeys and reasons for a developer portal or developer to want to use or need to use the developer portal every day to try and give that value whatsoever. So that's again what we're looking at, kind of smaller examples. So for you use like modules or kind of that form right before the IDP. Well, if we've got a pretty good module system, we actually created a scaffolder where all it does is add a Pulumi module to your existing project. Makes it very easy. What Pulumi modules exist? What is the platform team stood up for me if I want to make an S3 bucket, or if I want to make an API gateway module, like, is there an opinionated thing for this? Well, the old process was go look over here or ask another engineer or look at this repository over in GitLab. Whereas now it's like there is a scaffolder for that specifically. So it kind of changes that to, we want to try and get more and more. The first instinct should be to look in the developer portal and see if it has something for me there. So that's establishing and fleshing out more of the search capabilities, more of the tech docs. I think getting code search in line is something that was sort of a pie in the sky for us. We want to try and get that in. We'd like for there to be whatever you're looking for. There's a single search field. It'll pull up if there's a scaffolder, if there's a module, if there's documentation to that effect, if there's a team working on it. Like we want that to be all in one. To just drive more of that daily task workflow, and then it changes from this thing that you have to remember exists to go find whatever to this thing that you're in all day anyway. And so why wouldn't you start there looking for it?
That's a very mature platform engineering practice, by the way, if I may say so. So James, I'm sure that you have quite a few regulatory requirements in your org. How do you interface with your security team? Were there any challenges getting buy-in from security in allowing an automated, assuming that you do have an automated process to production, but was there any challenges in getting security to buy in to a more sort of green light by default model?
I think one of the things that really helped us out there was that with Pulumi, both through the use of policy packs and just through the actual way that we're deploying it, which is to sort of provide canned modules that folks can use off the shelf, it gives us some really strong levers to say, there is simply no way to create non-compliant infrastructure in the first place. So I think that was a big goal for us from the start, is to say, how can we enforce those kinds of requirements, whether it's tagging or, security group rules, anything like that? How can we enforce that from day one? And so I think that was something we could present to them and say, hey, look, this is actually a goal of ours as well, right? One of our, I would say historically, one of our big problems has been that we don't enforce much in the way of the shape of infrastructure with some of our existing tooling. And so that's something that we wanted as an infrastructure team to say, if we want to roll out a new feature, how can we be sure that everybody's existing configurations are relatively the same shape? But also from security side, they want to be able to say, are we compliant with these regulatory frameworks? So having the ability to enforce that, at the preview stage, even before things get deployed to prod or even to dev, to say we're enforcing this via policy packs and also via just what is possible to be created in code, was a really big win for both us and our security org.
All right, so let's talk about platform adoption, platform love. How do you how do you, depending on your scale, right? So if you're huge scale, also just for real quick, how many developers do each of your organizations have that are consuming your platform?
Tough to say exactly, but I'd say there's probably closer to 200, where it maybe isn't just software engineers, but also general infrastructure folks. So one of the joys of bringing infrastructure as code, as part of our challenge has been we've had a lot of infrastructure people have to look at code, and that's part of we talked about the multi-language and multi-language model earlier. One of the selling points there, and one of the easiest acceleration points, has been to show some of the like a server engineer. Look, it's just expressed as a YAML file. Like, well, it can be expressed as code or YAML. It really does the same thing, and so getting people on board with wherever their comfort level is has been nice. But all in, I'd say there's about 200 people that are trying to work with Pulumi or the platform here.
And so how do you manage your relationships with those application teams? Do you know all of the leads personally, or maybe like, use an envoy model where, each platform engineer on the team is responsible to, they're the primary point of contact for some number of app teams? Or, are you using more, research-backed methods like satisfaction, developer experience surveys and satisfaction surveys? How do you measure both the level of love for your platform and the actual level of adoption?
That journey for us is still fairly young. So with a year out of development, we've really started to integrate with our first teams. I'd say this quarter, really, as far as we've got a lot of good stuff built. Let's see it, and that was because we had an opportunity. We're trying to phrase it as a carrot, in the sense that we've had a lot of good InfoSec people here, and that means that they've had a lot of good cloud scanning tools and so forth. And the reality is that once you pick up something like that, like an out-of-date version of this or that, whatever the developer was doing or whatever that team was doing that week is now replaced by, you've got to update this Kubernetes version or something they're really not all that interested in worrying about. So having that scan up front while they're in it, while they're looking at their code, while they're trying to get whatever they're done with, actually is a lot more. I think that's a lot more empathetic than coming around after the fact and like delivering a list of findings of things that they have to fix that they weren't planning on working on that week.
Surprise! And you're making the stick out of carrots, which is an excellent strategy. Okay, so it is the year of our Lord 2025, and there has to be an AI question. So how do you see AI having an impact on your platform? Either today, in the future, will there be an impact? And you might even want to break that down between like, how do you see that evolving for your application teams? Or do you see like SREs using it more for like operational concerns? What type of scenarios are you seeing today? Do you see in the near future, or do you envision for the far future?
I think there's a couple things that come to mind for me. One is sort of in that similar vein that we already mentioned, I think, with insights of like gathering sort of an overview of what's the current landscape look like, right? So one of the things might be, looking at existing cloud resources, trying to get a general sense of what the shape of things is, group things into, relatively large buckets. But the other thing sort of that you touched on a little bit there is from the SRE side, incident response. I think one of the other things that we have seen a little bit of a challenge with is sometimes understanding impact of issues across teams, or understanding root causes, sort of different. I guess I would phrase this as sort of different directions of the same problem, right? Is sort of understanding how problems impact or manifest across services or systems. And I think maybe one of the big areas of opportunity there is for building in some of that deep, complex understanding of how all of the components of our systems fit together, so that, somebody on maybe the mobile team who's not as familiar with our airports or our Clear One business might be able to understand, okay, here is the issue I'm seeing. Here's maybe how it fits into the broader landscape of Clear's architecture. Here's the root cause. Here's, other systems that might be impacted. So I think helping folks get a better overview of how architectural components fit together is a big opportunity.
Yeah, I think that's, personally, I have a semi-skeptical view, I guess, of AI. But one of the things I think it is excellent at is summarizing things, maybe picking out interesting associations that you might not have found. So it's like really, really good for like suggestions, you know. I'd like your perspective on this since you run a small org. Are you, do you see your organization either today or in the future leveraging AI to perhaps sort of like to use an expression, punch above your weight?
Motive Care has got a lot of AI initiatives just in general. I mean, you kind of hit, I think, one of the most clear use cases for AI is summarizing a lot of data pretty well. So we've got a variety of success stories and like small buckets of the organization, right? Like I mentioned a strong InfoSec posture. That means we have a SIEM that's aggregating just tons and tons of log data. And that's really, really useful to put an AI engine over the top of that. And we've proven some strategies for that where, this thing picks out and draws associations between all these different data sets. Frankly, impossibly better than even a human could, right? Like it's too much of a fire hose of information to really see that coming. So taking some of those wins in clear cut, kind of narrow scope things, and then bringing that into platform engineering, where the whole point is to get all these different disconnected data sources. So into a single pane of glass, I kind of foresee something where a network engineer could come in and ask our developer portal, like, what code is provisioning AWS firewalls out there? Like what's defining the VPCs? Where does this subnet live? Just plain English questions, and then getting a pretty decent summary of like across these 4 repos, crawling up all these stack references, doing all these things. Like here's where that subnet exists. Like, oh, cool, thanks. Moving on.
What network paths exist between different entities?
Yeah,
which is a very, very hard problem to solve. And when I was an infrastructure engineer, there was that like sort of old trope that like it's always the security groups.
Right, and that's useful there, and it's enriched by a lot of other platforms that are doing AI. So Pulumi Insights with its AI query, we're using cloud scanning like Orca. It has an AI summary, so just kind of bringing all that into one place, or at least making it aware that if you didn't get the right answer over here, there's at least these 3 other integrations where you could try asking them. Like that'll be something we possibly bring in before making it a nice layered, sophisticated single query kind of approach.
All right. So I wanted to thank all of our panelists for joining us today, James, Zachary, Simon, and thank you for spending your time with us. And we hope you enjoy the rest of PulumiUP. So long, everybody.
All right. Hi, everyone. I'm Megan from Pulumi, and welcome to the Q&A live portion of PulumiUP 2025. We've seen a lot of highlights today, a lot of announcements, and great customer use cases. Just to kind of summarize some of the highlights from today, we learned that we shipped Visual Infrastructure as Code Import tool. We saw the new private registry. And last but definitely not least, we announced Pulumi IDP, our new product to manage all of your self-service workflows. And so we now have Joe on screen here, and we're going to be taking questions. So please feel free to post questions in the chat, and we can get started. So jumping into a question here. Joe, one of the things you talked about in your keynote is some of the migration tool improvements that we've had. And so I'd love to hear from you, what is the migration path for customers who have Terraform heavy environments? And what's new, but what's kind of the standard things of how to do things?
Yeah, great to have everybody here. Thank you for joining us. Really excited to get to be here semi-live today and field the questions. Yeah, I think it's a common question we get. People get really excited about the Pulumi way of doing infrastructure as code and Pulumi IDP, and they want to see a path from where they are today to, full Pulumi. But we know a lot of folks are coming from Terraform or CloudFormation, or maybe they manually point and clicked in the Cloud Console. A lot of folks coming from CDK as well. And so we have a variety of tools in the tool belt to help get you over to Pulumi. One is the Visual IaC Import tool that we saw today. That's sort of an easy way to get started, just because it's very visual. You point and click, you group things, it gives you the code that would have produced the infrastructure, and then you can kind of run from there. And it doesn't care how you spun up the infrastructure, right? So if you've just got a pile of resources that you want to get into IaC, that's typically, an easy way to go. We do have at the command line, we have the Pulumi import command, which is basically,
using the same approach as the Visual IaC Import, basically. It's just at the command line. However, if you have spent a lot of time as an organization invested in Terraform, we do have the ability to convert Terraform HCL and preserve the file structure. You convert Terraform modules to Pulumi components. And so it's kind of nice if you've been thoughtful about the way you structured your Terraform infrastructure as code, it's going to preserve a lot of that. And by the way, we have the ability to coexist as well. So you can consume an output from a Terraform workspace. If you've got your VPC over there and you don't want to touch it right now, you can just grab that VPC ID that's exported. And we just launched a preview of Terraform modules where you can actually deploy Terraform modules straight from your Pulumi code. And that's really exciting too. So we love your feedback on that. Those are basically the tools that you have available.
Yeah, thanks for that overview. I think that using a Terraform module from within Pulumi is definitely helpful for customers who have a lot of Terraform and it's going to take a while to migrate. So that coexist notion is a nice option to have. One of the things I wanted to ask you about is obviously Pulumi IDP is a big new product for Pulumi. Is this just a new layer on top of infrastructure as code? Like how does this fit into our existing product suite? And I'd also like to hear what kind of led us to going down this path.
Yeah, I'm really excited about Pulumi IDP because it's basically an evolution of everything we've been doing for many years, right? And the story of how do we decide to build Pulumi IDP, well, increasingly over the last 18 months, 2 years or so, we just kept hearing from customers, what we're doing with Pulumi? We're building an IDP. And then we pattern matched. And it's great that people are building IDPs with Pulumi. Don't get me wrong, I love it. The real shame, though, was it was taking them a long time. It was taking, 12 to 18 months to build out their initial platform, which is sort of a detour from what these teams ostensibly want to be working on. And there's just so much undifferentiated heavy lifting that we heard time and time again, pattern matching, that we said, hey, we just have that out of the box. And the great thing about it is it leverages all of the work that we've already done around components and templates and policies and ESC, the security model, and insights. And without all of those building blocks, we couldn't have built Pulumi IDP. But it all just kind of came together nicely under this clean umbrella that actually solves a very discrete scenario that we're seeing a lot of our customers needing to solve.
Yeah, makes a lot of sense why you get led down that path if all those signals are pointing us that way. Talk to me a little bit about the developer experience of this model you talked about in the keynote of having the no-code environment, the kind of middle ground of low code or the full code, and how you can kind of move across them. What does that journey look like for a developer?
Yeah, that's actually one of the things that made building Pulumi IDP hard was, although we were pattern matching, one customer wanted YAML as the interface. Another customer wanted a Kubernetes operator. Another customer wanted, point and click self-service in the UI. And what we realized at some point is it doesn't have to be an either or. We can actually support the full array from no code UI to low code YAML to full code with infrastructure as code to even REST API scenarios where maybe you're integrating to a broader, workflow solution. And some customers actually move between them, right? You might want to start with a no-code experience to get started, but then once you hit the limit on, the template and the customization, maybe you want to eject into YAML or even full-blown code and go from there. And so we wanted to support this multimodal polyglot kind of experience. And I think that was sort of the magic. Once we had that insight, I think it all came together.
Definitely makes sense. We did have a question from the community here. I'm going to read out. Does Pulumi work with on-prem Kubernetes and related infrastructure? And I'll maybe expand that question to not just talking about on-prem Kubernetes, but then separately, if you're a customer who needs to have things in an on-prem, in their own environment, not on-prem, but an isolated environment, what are Pulumi Cloud's options for self-hosting? So we can start with on-prem and then migrate to other compliance requirements.
Yeah, I think there's two dimensions to consider. One is where does Pulumi Cloud run? And then two, what resources are you managing using Pulumi? The first, Pulumi Cloud, we do have self-host edition. It can run in even extreme air-gapped environments. It can run in any cloud. It can run on a VM, in a Kubernetes cluster. Of course, Pulumi Cloud is really easy to use. It's a SaaS. Our security model is pretty novel there, where a lot of even Global 2000s have gotten comfortable just using our SaaS because basically the client controls the authentication with the cloud. Then the second question is, okay, what resources are you managing? And we definitely have folks managing on-prem data centers, vSphere clusters, even OpenStack in some cases. So we do have providers to manage on-prem infrastructure as well. And you can mix and match those. Because the client is actually authenticating with the cloud, you can even manage on-prem infrastructure while using the publicly hosted Pulumi Cloud. It seems like that shouldn't work, but because Pulumi Cloud doesn't have direct access to your infrastructure, it doesn't need to actually talk to your on-prem resources. So every permutation is possible.
All right. Let's jump into some live ones. I'm going to read it out here. Pulumi's current pricing is based on the number of resources, but I see that potentially at odds with the goal of infrastructure as code. It can create friction when deciding whether to manage additional resources through Pulumi. Have you considered other alternatives, and like how do we manage this as a user?
Yeah, it's a definitely good topic. And the reality is we typically work with customers to find, a pricing solution that works for them. What's maybe not obvious, we need to probably do better in our marketing, is that we do actually do pretty extreme volume discounting for teams at scale. So, if you're just multiplying the list price you see on the website, that's not going to really tell you the full story. But we do work with customers all the time to find, a price point that works for them. We've actually switched between pricing models, 3 or 4 different times. And what we found is there's kind of no perfect model. And at least with resources, more resources means more cloud infrastructure being managed. It means more people spinning up infrastructure, more complicated environments, more, worldwide deployments. And so we found that it actually tracks closer to customer success than any other metric. But again, we work with customers to come up with something that works for them.
Makes a lot of sense. And then our last question, we're coming up on our 10-minute mark here. So we'll take one more question from one of our viewers. For engineers who have developed a lot of expertise with Terraform, what are some ways to train them to become as proficient with Pulumi as they are with Terraform? The fear of ramp-up costs can be a huge hurdle for adoption.
Very, very good question. And the thing to know is for everything in Terraform, there's basically an equivalent in Pulumi. And, we may call it up instead of apply, but, there's a lot of equivalents in the commands you run. So there's sort of two layers. There's, the CLI tool and the workflow, and then there's the expression language, going from HCL to using a language in Pulumi. And the good news is, really the subset of the language you need to know to be proficient in Pulumi is actually less daunting than it might seem. I mean, if you look at a Python program for Pulumi, it's very declarative in nature. I mean, you're just declaring objects with properties on them. And so I think it's really important to sort of demystify both of the workflow and the language and understand going into it that, hey, they really are sort of, equivalent. There's obviously big differences once you get to more complicated scenarios where you're building components and that, is going to be different. We have some training material. So we do training for customers all the time, onboarding to help, so you're a Terraform engineer, let's help you become a Pulumi engineer sort of training. So just know that we're always happy to do that for you. We also have materials on our website. So I can't remember exactly where it is, but it's in the docs and it's like, Pulumi for Terraform folks. And we just did a recent video as well. So I would check those out as getting started, but always feel free to contact us if we can help you more with that.
Awesome. Well, thanks so much, Joe. And thank you all to the community for being here, for being part of PulumiUP. As Joe said, this is something we all look forward to a lot, and we're very excited to be here and to be doing this again. And thanks for all the great questions. That was awesome. I guess, any final thoughts, Joe, before we wrap things up?
Yeah, so thanks for hosting this, Megan, and thank you everybody for joining. As Megan said, this is like the highlight of our year, so you all just made my day, and definitely appreciate you joining. Hopefully you're as excited about Pulumi IDP and some of the stuff we launched today as we are. Obviously, we're just getting started, and so we'd love to hear your feedback if you give it a try. It is free to get started. Just go to pulumi.com, click the Get Started button, and
let us know what you think. We have a community Slack as well, so if you want to drop your thoughts in there or ask any questions, we will all be on standby waiting to help out. But thanks again, great Q&A, and I look forward to seeing you all next year.
Awesome. Thanks so much, Joe. Yeah, just wanted to say we will be sending a follow-up email after this that will have the link to the slideshow as well as the recording. So if you want to share it with any of your teammates who weren't able to attend, you should definitely do so. Wanted to, in addition to thanking everyone, thank our customers, Clear, XM Cyber, MotiveCare for their stories here today. I think it helps a lot hearing it from them instead of just us. And also our partners at Docker, GitLab, Honeycomb, and Temporal for our workshop series starting May 14th on platform engineering. And from all of us, thanks for attending. It was great, and we look forward to next year. Bye, everyone.